Yes, good morning, everyone. Sorry for the technical problems. We will now start. Hope you can still hear us. So today we were thinking that we can a little bit recap what we saw last time. And then hopefully everybody has done the homework so we can check also how everything went and the results. And also if you have questions, you can make it, or if we do not have time, you can also send for us later. Okay, so let's go to this part where we basically had our data. So everyone had these files here. Where we had spectral features plus vegetation index features. Then we had only the spectral features, and we had the vegetation index features. So then one of the tasks was compare, like, for example, when we are using just the spectra and when we use both combined, and what would be the results. Then we also had the 3 classes, which is coming from the field data. So it's our ground truth to build the models. And we were using this code here, which I've updated, and so that there will not be one error with one of the files. And if you remember, we had this kind of files with the features where each column is a feature and then each line is our sample, our observation. And we have a file with our class. And these are the structure that we input into our machine learning classifier. And these were the numbers of samples per class, right? And we are using the scikit-learn here. There are other libraries, but this is one very common and the one that we've been using in our studies. Okay, so let's go to these steps where we were loading the data, we visualize the data, and then we start to build our classifier, our model, by splitting. So we had the validation. If you remember, we can actually go now to the code. So here I was importing just the packages I'm using. If anyone has a question about this, also just stop and we can go through. Here I will load the files. So let's use this first file here. So I'm loading the classes and the spectral features. And what changed from the last time is that I just removed the lines with none values, and then we don't get the error that some people had with the previous data. So is everything fine up to here? Probably. Yeah, great. Then we had the split of the data. So we had the training 75% and then the validation 25%. This is something that it will, you can decide according to the amount of data you have So sometimes it's also not possible
Tässä on vähän uudempi tykki kyllä.
Okei.
to have such a
Pidetään se sitten varalta siinä. Hei, antaa olla vaan.
25%.
Joo. Nimittäin
Tämä
tuossa,
voi vaan.
joo, kiitos. Joo, me vaihdetaan, jos tulee
Tässä on
tarpeen.
eri asetukset. Niin.
Okei, joo, kiitos paljon.
Kiitos.
Hyvä, että on vaihtoehto varalta.
Okay, so here we can see the amount of data for training and the amount of data for validation. And we were using the random forest. In your studies, you can test different models also. And here we define some parameters. There are several parameters here. We are just defining the N estimators and use default for the other. Then we fit the model and we use the model for prediction with the 25% of the data here. And if everybody remembers, we had the confusion matrix, which Roope was explaining last time. If there is any question also about this. And here we had the classification report, which you are gonna be analyzing. So we had for each class here. And if we still remember, the number one was the infested, and that had much less data, and it's often been difficult to classify, as it's similar also to the health class. And one of the tasks was also to consider, instead of 3 classes, 2 classes, so alive and dead. And now here I'm sure this is, I think, was the last part. We were looking through different methods to validate, so to do cross-validation in our data. Is there any questions up to here? Or is everything clear? Yep, good. So when we don't have enough data, there are some methods that can be used. So if we don't have, for example, data to let 25% out or 30%, we can use, for example, one of options is the leave one out method, where one sample will be always out, then we train the model with the rest of the samples, and we do this until we go through the last sample. So we have done this in some of our studies, as we had very few observations. And this method, if you have a lot of samples or observations, it will be quite slow to go through. As if you run this cell, you will see that it's a bit slow. Then another opportunity is to use a k-fold cross-validation, where here we will take part of the data. We define the number of splits, so we will split the amount of data in 5. And for each of those, we run the rest of the group will be like our training data, and we will have the classification model for each. So basically, we test the model through the whole data, always leaving one part out. And we can see the consistency also of the results. One common approach is maybe at the end you report the average of these values and standard deviation, so you can have an idea of this. So I think this figure is trying to show how it goes. You have the training data here, and we split the data, so this will be the validation, the orange bit of validation, and then we have the rest as training, and still we do this through the data. And we had the stratified fold, which is more common used when you have class imbalanced So if we run this, we will see the difference is that between the previous one is that it's trying to always keep similar percentage of samples for each fold, for each run. So this would be the most indicated for our case, for example, now. Yep. So is there any question on here? Okay. Yes, so then the next part is that we can always check the feature importance, which we got from random forest. So we see in this case, for example, it's already in order of importance. So we can see that these bands were more important, contributed mostly for our model. And I think if you remember when we were just visualizing the data, we saw that the blue and red were blue and green, sorry, were separating better our classes. So it makes sense.
We have a question here, and that is actually why few of us have blue bars, while some have color bars.
I don't know, actually. If you are, it might be related to this library here, because usually my computer is always changing my plots time to time. But you can also set up that different. Yeah.
So you say it's not no color selection here.
Yes, and
So I think that it's calculating the importance based on that how many times there's the big forest, like a lot of these trees. So how many times it appears there to be like the right one. So that's how it's counting how many times it has been like contributed to the model. So this is how it come there.
yes, and then the next step, what I'm talking here, is that we could try to get only the 10 best features and rerun the model. And here is one way to avoid, in some cases, we will have too many features and not much of samples. For example, what I told last time, for if we have a hyperspectral camera where we have 400 bands and we compute all of those features, the spectral ones, we will get a file with more than 10,000 features. And how to deal with that, and if you have maybe 100 samples and 10,000 features, so there are methods that will help to select features. This is one of the most simple one we can use, but there are also more automated techniques that we can use to select features. And this is one thing that we also have to think that we need to deal when we are building our machine learning models. Yeah, and the result is we're using only the 10 best features. In this case, didn't change much, so we can still see that it's similar to use all features. Yes.
Well, there's one online question. In which unit the importance is measured?
I don't know which unit, but you can, it's from 0 to 1, if I'm not wrong. And also depend what we are using here. I think the default is the Gini importance. But we can.
It's some kind of relative unit. I don't know if there's like, if there's not any kind of with that self itself.
Yep. So maybe we can, if there is not more questions, or is there some questions up to here, then we can go to the homework. Nope. Okay, so I tried to do the homework. And
Did you get some kind of results from homework?
and here were my results. So I run it for all the files that are there, and you can check if it's very different from mine, or I hope it is the same. So here we have the multispectral. The MS is multispectral camera, and then RGB, because I also added there the RGB features. So for the RGB camera. And we have only for the spectral features. Let's see if I improve here. A bit fine. Only for the spectral features, then only for vegetation index, and then they combined. From the confusion matrix, we can already see that the results are very similar for all the combinations of features we use. So basically we had also similar when we use the RGB camera. So if we remember about the two bands that we saw that were most important for our models, so they are also in the RGB camera. So it's making sense. And does everybody has similar results or something different?
What are the best results you have got for?
I don't know if we can call best, because it's very similar, but the RGB with the spectral was the best in this case, this one. But the other ones are like basically same,
Left
9 to 1. I would not say that 9.3 is very different from 9.1.
Does anybody have better results?
Yeah. So in this case, I just use the results I'm reporting here. They are the first cells where we just train the model and check the test. So there is no feature selection. There is nothing different.
and validation, leave an out or default?
No, just with the data, 25%.
Yes,
just they split.
There's a question.
Yeah.
How many times did you run these tests, and did you use randomized splits?
No, I didn't use it. It's just the I run once, but I'm using like same random what is that here, random state, so it's gonna keep the same result. And I was not using any cross validation. I used just this first. Sorry. Where I split the data in training and test. So
Yes, thank you.
yeah. Yes. And then go again here. Yep, and here is the next. So if you also have done this part B, where we have so what I did here is that I 2 pluses. I added just one more line here so that all the classes that was 1, they are now 0. They're now like health or alive.
Yeah, so you change the
I just
class
changed
to
it.
the alive class.
Yeah, so then we got more samples for the, oh yeah, I didn't run this. Then we got more samples. And I think the results are quite what is expected, or we have dead and alive. So we got 1, 3. There was actually 3 for each test. For most of the tests, it was basically same 3. There was two 3s that were being confused, and it was basically some issue with it was a little bit similar to the infested, let's say. So the color was not so clear. But yeah, I think these results are what we can see also in literature, right? So quite good. And again, very similar for both cameras and the 3 feature combinations. So that was very easy classification task to everybody. So do you have any questions for here?
Yeah, thoughts about how to say the number of features. You say, for example, taking the 10 best features, why 10 or why 8 or why 20?
No, that was just a guess, like, yeah. But yep.
I think there are some recursive ways also to select. That you will try to minimize it. You run it like always, put one out and see if it's still working. You're getting similar.
Here.
I'm not sure if we have now implemented the recursive.
Yeah.
Here.
We can.
Yeah, you have something about the feature selection more.
Yeah. So we go here. There is some guides about, but here, where was it? Here, feature selection. Yeah. So if I'll try to a bit more talk about the feature selections. Let's go back to this part actually. So just the basic workflow, but not the, doesn't mean that you have to follow all of these steps. You can think about your data and always analyze first. So we had the features, the classes, the labeled data, and we did the data exploration. We check if everything is good, there's no data, and we can use some filter methods to already reduce the number of features. So for example, when I talked about the having thousands of features, they are probably correlated. So you can compute correlation and also, or you can compute the variance. And so there are several methods where you filter already some part of your data. Then we can split in training and test if we have enough data for that. And when we have the training, we can use some loop where we can use a feature selection technique. Basically, we did just taking the 10 best was one example, but there are, for example, recursive feature selection method I can show. Then there are other methods where it's somehow some techniques that we try to select for you the best features. And it does this with a cross validation, like you can use the the cross-validation like k-fold or stratified, so that it will always validate. And then you can also add there a method to try to optimize the parameters. So this can be also very time consuming, and you can have overfitting. So everything should be thought or checked that if whenever you have a knowledge of your data, if you can already use this knowledge before to remove features or to select the model parameters, you can use this. So you avoid some extra computations. And then we have the model, and we can test the data with our test data validation. So is this clear, more or less, the steps?
Just can you tell more about this selection of the best parameters?
Yeah.
This maybe next step.
Yes.
Can you visualize this classification in math? Can you use some pattern?
The results. So the problem is that after that first day, I cannot open the QGIS anymore on my computer. Yeah, it is. I tried several times, and I don't actually have the rights to install, so that's why I didn't reinstall. But I think.
But in principle,
Yeah.
it's possible to.
In principle, yes, it's possible to visualize. You can also, if you have your model, and you can then use the final model to classify all the other trees if you extract the coordinates of them and compute the features for them. So then you just do the prediction, and you have also the other trees which were not used as reference classified. So then you have a map of dead and alive. So basically we use the final model for that.
Do we have some script in Python created?
That does the second part. Yes, but basically we have here also what would change is we will load the file for the new data or the features for the other trees that were not used in training. And when we have the final model, we use this prediction here. I don't know if everybody can see it actually. So we will use predict, and here it will be the data which you load with the extra data, like the other trees, the remaining trees, and then you have your prediction. So you have your classification for the other part of your area. So basically, it would be this.
Okay.
Yeah, and of course, if you selected features, you have to remember before put here to use the same features that your final model is using. So as we did here, we just use the features like the 10 best. So you would use the selected features. Yeah. So your question was about this part. So
Optimized.
yeah. So there are some techniques. I'm linking many things here, so then you can go through. And one example is this grid search. So you can define in this case, we were defining for random forest model. So we were defining here several parameters that we can test. And the grid search, for example, will try to create a grid with all combinations. And then it will run this use a cross-validation method. So basically here you define the cross-validation, and we are using stratified because we have unbalanced. So we will use the similar idea.
And there's a follow-up question for the previous question online. In my testing, I saw a score standard deviation of approximately 0.03 in 500 randomized training test splits. How can you trust the results of the feature importance or parameter selection, given that the scores are random to this degree?
I saw a score standard deviation.
Do we know what is?
Yeah,
score
what is
standard
the
deviation?
score standard deviation? Tony, what you mean? Yeah, if you can. Yes, okay. But the validation data will help you in this part because you are not use. Okay. Do you have an example of classification you see and what if we have the LiDAR or RGB for classification? No, I don't have an example of CNN. In our group, we do work with this, so Emma would be the best. But I don't have the example for CNN.
Maybe this data
At
would
the
not be enough for to do this, or what do you think? There was like about 100 trees, 91 trees.
Yeah.
I think it is a very small data set
Yeah.
for
Yeah.
CNN. So I
Hey,
would assume the results wouldn't be that.
Yeah.
Right.
okay, so now we have the next number is coffee, and then we will have this international presentation at 10 o'clock. So it's like 12 minutes.
Yeah.
until that.
Okay. So just I will just have 1 minute to finish. And Tony, if you want to send me email, I will try to answer your question. So yes, as I just told you, we have some techniques that can try to optimize the best parameters, and techniques that will try to select the features so that you don't need to go there and put I want 10 best. And basically they use the cross validation. So for example, a feature selection, you can put a recursive method, which will try all features, then remove one feature, run several times, and so on. And yeah, at the end you get your final model and you have still the test data for validation. But I will share with you all the slides, and I tried to put more links here on this new version so that you can go through the documentation and also some other links. And I hope that these basic steps will just help you to go to analyze your data. And if you have any question, you can just also contact me still. Yep. Thank you, everybody.
I have been trying to update them with the different topics that we have heard these days. I have made some updates based on this. And I find my presentation mode. Yes. So we had these two different perspectives. First is the remote sensing technology that we have heard and learned during this event. So like I was dividing it further by the application. I'm sorry, these are my boxes are now too small. So I was dividing it by the application for which task we are using this in this vegetation or forest disturbance management. So there were this like monitoring dead trees and so on, using satellites, aircraft, drones. And then another topic was this more like early detection, so looking more accurately on forest. And so what we have now studied here, so we have different resolutions. Actually, there have been also resolutions over 10 meters, and maybe I should also add here Hanna's presentation somewhere. I did not add it here. Sorry about this. It just came into my mind that there was also something useful for that. But mostly the presentations have been, there have been these 10-meter ground sample distance, this sentinel type of analysis. So there we have heard this Teija Kattenborn's presentation, where he is thinking of using drone data as to train satellite models in order to evaluate globally tree mortality. So that was very interesting, and it was also like invitation that if somebody has suitable data, we can send it and contribute to this effort. So it sounds very interesting possibility. And then just this Lars Eklund presentation about following phenology and calculating cross primary production and this kind of things. So it was that. Then I had also this 1 to 5 meters that are, for instance, this Planet Lab and this kind of products. I think nobody was talking about this kind of products. Samuli's presentation was about this 30 to 1 meter ground sample distance. He was using aerial photography collected nationally. Like in Finland, we get one set every 3 years. I think different countries have different temporal resolution in collecting the national data. Then we have this 5 to 30 centimeter resolution, and here there were presentations by Teija Kattenborn. Yes. Okay, then we go to early detection. Actually, I was thinking I should have had this RGB drones, Emma's and Teija's deep learning presentation. I was thinking to put it here in the upper row, but now it's in this early detection, so I will move this up later. We will share this also with the training material, so you will have the accurate thing then later. About the early detection topics, so we have had the multispectral drones by Emma. So there were this Kellu type of drones capable of collecting large areas. So this is one important development trend also, so that we are getting these beyond visual line of sight drones. Then there were presentations about hyperspectral imaging. So Ilkka Pölönen, Pynek Malenovski, and Langning Huo have been talking about these. Then there were two novel topics still, inside forest drones and multispectral LiDAR, that were not covered in this workshop. Okay, then there is this another few what kind of remote sensing analytics techniques we have been studying. So first of all, we are talking about machine learning. So we are talking about supervised, semi-supervised, unsupervised, and here always there is some kind of, we are trying, we have a lot of large data set, and we are trying to learn from the data set something and making some models and using that. So we have here the classical techniques, and deep learning techniques. Actually, I have divided all of these topics, these two classes, because there are a lot of useful techniques in both sides. So for classical, we actually had only this hands-on. And then about deep learning, there were several presentations by Ilkka, Samuli, Emma, and Teija today. So deep learning is, of course, a big trend, but as we have heard, deep learning requires a lot of data, so it's not useful in all cases. So also classical, they can be useful in many situations if there is not that much data. So principally, we have not covered the semi-supervised, unsupervised techniques, but there are also a lot of development in these techniques, and they are very useful also. And then there were these two a little bit different ways of analyze. There were this quantitative parameter retrieval utilizing radiative transfer modeling. So Zbynek-Malenovsky's presentation was excellent presentation about that. He is one of the top scientists in the world doing that, so it's very useful. And we have also this presentation available, so we will share it later. And I think also Lars Eklund's presentation goes to this category. So principally, he was using this radiative transfer theory as a background when he was deriving these different indices. So that was also, I put it to this category. And then there is also this analysis of indices. So Langning's presentation and Lars Eklund's presentation are here. So actually, advantage of this type of techniques is that principally when you find good indices, then you can analyze them directly from the data. So you don't need great training data in practical operations. So they are very interesting also. And for instance, if we want to develop some tools for early detecting green attack or something like that, they could be very efficient in developing fast solutions. What are needed if we want to act in 10 weeks after swarming or 5 weeks. Okay, so this was some kind of summary about the presentations and lectures we have been hearing today. Does anybody have any questions and comments? Not any comments. I hope that you have liked the content and found it useful. So there were something hands-on and this kind of very concrete training, but then also different perspectives to the topic, so that we don't just focus in one type of analysis, but you see that what is happening in the world. I think this covers quite nicely topics. Actually, I have here the last slide. It's brainstorming. If we still want to cover some topics about remote sensing of vegetation health and forest disturbances. So any further ideas about topics? Yeah, what would you like to study? And if we invite more lecturers or give presentations. So I think that one topic what was earlier discussed, we did not cover it very well. It was like data calibration. So it was like hyperspectral, multispectral, and so on. That was one topic that we did not have time to cover in this training. Any other ideas?
Just ask, this is for next meeting or?
Yeah, potentially, yes, because we will have more training events coming.
Okay, easier, okay. I think that somehow there is this combination of subflow data and 3 dendrometers data with remote sensing data, and Miro started to have presentation, and we had the data from Slovakia and from, I think, from Finland, maybe from Sweden, but somehow how to join this to the different data set. We have like subflow data and these dendrometers in time, and then we have remote sensing shoots, and maybe I even didn't see any paper joining this. There was a paper of Marek Chauvin, which was done this work by Miro machines, but maybe this is quite a nice topic.
Yes, I agree. Very good.
In chat, there was one idea.
Yes. So deep learning training is one topic that should be also covered.
Or how to use artificial intelligence in these topics.
Yeah, so of course, like machine learning, what you have heard here, it is like part of artificial intelligence. It's like one part. So principally, we have already been discussing about that somehow. So all the methods that we have heard, they belong to the artificial intelligence. So deep learning is one technique in machine learning. So this is also one. Of course, maybe big data analysis, but we don't always have big data. So this is like one
But
challenge.
subflow and the dendrometer data could they be considered as big data or not?
At least they are like a hypertemporal analysis. So yeah, maybe big data is that we have huge amount of different observations. So that comes we have a few trees with these dendrometers and so on. So we have information about a few trees, and it is very valuable. And I think that it is a good topic. And we have been also talking about this because we have now like drawn data time series from the areas where there are also the subflow and dendrometer measurements. So we have now possibility to investigate it. Yes, and I think that it was also in this RESDiNET, like our initial project plan, that we will study this subflow dendrometers and these remote sensing. So it is well aligned. So I think maybe the next time that will be the major topic, hopefully. And I think SLU will be organizing that part then.
How are we thinking around in those data about the subflows and the parameters? There are quite few trees that we have. How are we pooling the data? I mean, we have trees, you have trees, everybody have a few trees.
Together we have many trees.
Yeah.
But maybe we have checked the data from 100 trees in one area.
That's what.
Yes, but we have as well remote sensing the data, but nothing is perfect. This data are never perfect.
It's good to have this like sample sensors across similar trees, so we have a chance to actually derive the variation across the trees. Of course, if we can put a remote sensing that would be useful.
Because I just this is for Miro, but do we know any paper who joined this remote sensing data and subflow data?
No, exactly.
What?
No. There are some attempts in some crops were observing the other factors which concerning growth or water content and something like this, but not exactly the same as subflowing trees.
It's somehow left to us But we have to be the first. Okay. Okay, I think this is still the biggest thing is how to join this kind of data. I think that is still open question.
Yes, and then so that everything has to be together, or is it there can be more these dendrometers and remote sensing or dendrometer observations than subflow? So it seems to me that it's easier to use dendrometers than subflow
For sure.
measurements. So there are more than data. Yeah.
And I just my live question is it chance to put this data somewhere and ask artificial intelligence to do something from it, or this is too futuristic?
Yeah, to write chat GPT, please analyze this data.
Yes.
Yeah, we can try.
Do you have anything about forest soils and drought problems? Because that's very important issue, because soils are affecting tree resistance and tree health.
I think this is like we have this soil water potential sensor. Yes, I think we have this sensor in Slovakia for sure, and something in Czechia. But I go into this my chat GPT, but maybe there is some better tool like chat GPT who can do it, which can do it. This is something like open area. But because this is my best friend, this chat GPT, especially that night when no one is speaking with me. But that's pretty cool. But maybe such approaches could be helpful. But I don't have an idea about the development in these places.
Developing a bit of soil moisture sensitivity with the radar systems. We're going to carry out some experiments this year. So potentially we could, depending on the outcome, present something like that.
And are you going to do it in Umeå or in this southern Sweden?
It's just Umeå.
Okay. And these are tower like with radar and.
Yes, but also with ground penetrating radars and with the drone-based radar system.
Like what
Ground penetrating radar. It is like
radar.
Yeah, a radar that is operated on the ground, but that is shooting into the ground, into the soil.
And this is something like small car, is or?
Yeah, it is a small vehicle that you're pushing in front of you.
So you can carry that in forest stands. Okay, that's clever.
Because I think this is, it could be like places like this Koli here, I think.
Yeah.
But
I was also thinking the same.
Maybe you should speak with 5E and maybe somehow bring this your thing to Koli.
Yeah, so we need another workshop.
Yeah.
Okay, but you plan to use this ground penetrating radar in your area, and you are going to have map of this soil moisture.
Yeah, that's ambition, but I don't want to promise too much. So
And what is going to be your map? Like you are going to make points, and from this you will start digging.
we already have soil moisture point measures. We want to like cover the areas in between with this ground penetrating radars and see if we can actually find a way to map that type of variation with the radar system. I mean, it's reacting to the soil moisture and also to the density, so rocks and other objects will also be identified. But it is a lot of different sources that may affect the outcome, so that is, I'm very cautious to promise too much so early.
And what is the size of this area? How big is it?
I mean, since it's mobile, we could move it around, but the area of interest that we are focusing on right now is about 0.6 hectare.
And what is how often are you going to use it?
It's not entirely decided yet, but yeah, we're still discussing. We have
Once a month or something
like 4 times per season for the next 2 years. But yeah, it depends on a lot of things that have not been decided yet.
Yeah, probably it should be taken at the same time of the day, early morning, or fix also the time. Yeah. So how deep is the measurement? Is it half a meter or 1 meter height?
It depends. It depends on the soil density.
Okay.
And the moisture. So it can a few meters.
A few meters.
In best case, but that is also one of the questions that we want to investigate.
That's really interesting. Really interesting. Yeah.
Are you planning to look at root traits as well?
Yeah, that is one of the drivers why we want to have it. But also to optimize, for example, planting points, so you can avoid trying to plant something where you have like rock very shallow.
Yes, okay, that was also very interesting. It is possible that we have in Finland also some ground penetrating radars, but let's see. So I think that we are now coming to the end, 2 minutes to lunch. So I guess we will now stop the event. Thank you everybody for joining and being very active. It has been very interesting, at least for me. So thank you. Is the people still in internet also maybe? So many thanks also to our online visitors. We hope that you have found our training event useful. So thank you. We will now close the session. Goodbye.